Okay, kids, we're going to do our last section in Unit 8 today, solving rational equations and inequalities. We've seen these on the EOC practice test. We've done some in other classes, in other units. Today we're going to look at examples 1, 2, and 6, beginning on slide 1292. Okay, let's get started. Example 1 wants us to solve 4 over x plus 3 plus 5 over 6 equals 23 over 18. Earlier in the unit, we combined rational functions, and we could do that here, cross multiply and solve, but I think the easiest thing to do is to get your least common denominator and clear the fractions. So when we look at our least common denominator for this one, 6 and 18, there will be an 18, and then that denominator of x plus 3. So in clearing it of fractions, I'm going to multiply this by the LCD. All right, let's look at that. So when I multiply the first fraction by 18x plus 3, the x plus 3's cancel and I get 4 times 18. When I multiply the second fraction by the LCD, 6 goes into 18 3 times, and so that'd be 5 times 3 times x plus 3. And when I multiply the fraction on the right side of the equal sign by the LCD, the 18's cancel and I get 23 times x plus 3. Now I have a linear equation that I just simplify. 4 times 18, 72. Here I'm going to distribute my 15, so that's 15x plus 45. On the right hand side, I'll distribute 23, and I get 23x plus 69. Just collecting like things, I get 15x plus 117 equals 23x plus 69. I'm going to move my 23x over here, my 117 to the right hand side, subtracting those, and I get negative 8x equals negative 48. Dividing by negative 8, I see that x is equal to 6. Now you can do a calculator check and make sure that the left-hand side equals the right-hand side. So if I put a 6 in here, I get 4 9ths plus 5 6. I could add those together and see if I get 23 18ths. It checks. One thing that you need to make sure of is that you don't get something that's extraneous, and that would come from a restriction in your domain. This x plus 3 makes a restriction of x can equal negative 3. If that had been a solution, then we would not have gotten a check. Okay, let's move on to example 2. On example 2, solving again, we have 2x over x plus 5 minus x squared minus x minus 10 over x squared plus 8x plus 15 equals 3 over x plus 3. So in simplifying this, I need to factor the denominator so I can see what my LCD will be. So x and x. What multiplies and gives me 15, it adds and gives me 8, 5 and 3. I have the x plus 5 in the denominator here, the x plus 3 in the denominator here. So my LCD is x plus 5 times x plus 3. So I'm going to multiply that to each one of the fractions. And when I multiply it to the first fraction, the x plus 5's cancel, and I get 2x times x plus 3. And when I multiply it to the second fraction, x plus 5 and x plus 3 both cancel, and I get the numerator. And I want to keep that in parentheses, so I'm careful not to lose a sign. Very important. When I multiply it to the right-hand side, the x plus 3's cancel, and I get x plus 5 times 3. Right, and now I'm going to distribute. I get 2x squared plus 6x, distributing that negative, minus x squared plus x plus 10. Distributing the 3, I get 3x plus 15. Collecting like terms, I get x squared plus 7x plus 10 equals 3x plus 15. Anytime you have a quadratic, you need a 0 here, so let's move these over. And I get x squared, I'd subtract 3x, and I'd get 4x. I'd subtract 15, and I get minus 5. You can use the quadratic formula. Factoring is so much faster. X and x. What multiplies and gives me negative 5 that adds and gives me 4 will be 5 and negative 1. And then from those two factors, I know that x is equal to negative 5 here, and here x is equal to 1. I could do a check, but as we talked about earlier, this factor in the denominator makes a restriction in our domain of x cannot equal negative 5. And here, solving, I found that x equals negative 5. I'll throw that away. It's extraneous. X equals 1. It's my only solution. Another x value that would have been extraneous would have been x is not equal to negative 3 because of that factor in the denominator. So x equals 1 is my final answer. I could do a calculator check on that. All right, and then our last example that we're going to look at is example 6. Very similar. It's just going to be an inequality instead of an equality. So on example 6, we have x over 3 minus 1 over x minus 2 is less than x plus 1 over 4. We're going to do it the same way. Think about our LCD. 3 and 4, common denominator there would be 12. And then we have that factor of x minus 2. So when I do this, I'm going to just think about this being an equal sign, and we're going to find what's called our boundary points, and then we'll test to see which ones work. So when I multiply this to this first fraction, 3 goes into 12 4 times, and so I have x times 4 times x minus 2. Here, the x minus 2's cancel, and I get 12 times 1. I'm going to think about this as an equal sign. 4 goes into 12 3 times, so I have x plus 1 times 3 times x minus 2. So I multiplied the LCD to each one of those fractions. Now we'll clean it up. This will be 4x squared minus 8x minus 12. On this side, I'm going to keep the 3 out for a minute and FOIL that, and I get x squared minus 2x plus 1x minus 2. Just doing first outer inner last. Still cleaning, I get 4x squared minus 8x minus 12 equals 3x squared. When I combine this, I get negative 1. So that's going to be minus 3x minus 6. Again, a quadratic, so I'm going to move everything over. So move that over, move that over, move that over. And I get 4x squared minus 3x squared is x squared. Minus 8x plus 3x is minus 5x. Minus 12 plus 6 minus 6 equals 0. Factor or use the quadratic formula. So x and x. What multiplies and gives me negative 6, it adds and gives me negative 5. Negative 6, positive 1. And then when I go to solve, here x equals 6, here x equals negative 1. Remember that a restriction in our domain, and this is an important point for these inequalities, because of that x minus 2, x could not equal 2. So 2, 6, and negative 1 become our boundary points. So still working on this one. Remember our problem was x over 3 minus 1 over x minus 2 is less than x plus 1 over 4. So when I think about a number line, my solutions were negative 1, 2, and 6. So I want to check less than negative 1, between negative 1 and 2, between 2 and 6, and greater than 6 to get my final answers. So here I'm going to substitute in a negative 2. So I'd say negative 2 over 3 minus 1 over negative 2 minus 2. Is that less than negative 2 plus 1 over 4? So is negative 2/3 minus a negative 1/4 less than negative 1/4? And I get here negative 5/12. Is that less than negative 1/4, which is negative 3/12? And it is. So that section checks. All right, I'm going to check 0 in this section. So I have 0 over 3. Let me change colors here. I'll put a 0 in, x equals 0. So I'll say 0 over 3 minus 1 over 0 minus 2. Is that less than 0 plus 1 over 4? So is 0 minus a negative 1/2 less than 1/4? Is 1/2 less than 1/4? No. That testing point did not check. Okay, something between 2 and 6. I'm going to pick 3. And I'll say 3 over 3 minus 1 over 3 minus 2. Is that less than 3 plus 1 over 4? Is 1 minus 1 less than 4 over 4? Is 0 less than 1? Yes, that one checks. And then on the last one, I'm going to pick x equals 7. So I'll say 7/3 minus 1 over 7 minus 2. Is that less than 7 plus 1 over 4? Is 7/3 minus 1 over 5 less than 8 over 4? So simplifying 7/3 minus 1/5, I get 32 over 15. Is that less than 2? Well, 32 over 15 is more than 2, so that doesn't check. So then my final answer for this one is x is less than -1 and x is between 2 and 6. A lot of ways you can write that. You can write it as an inequality. X is less than -1 in union with x is between 6 and 2. Or you can write it as an interval. You can say -infinity to -1 in union with 2 to 6. Now, since the original inequality didn't have an equal to line, we wouldn't have any brackets here. They would be all parentheses. Okay, and that's my solution. So once you get your equal to, those are called boundary points, you mark off your number line and you check your intervals. Don't forget to also include any restrictions on your domain on that number line. Okay, so we're going to finish our unit on slide 1303, and we'll do 2 through 8 even, 14, 20, 28, and 30. You can email me if you have any questions. Go back and look at the slide examples to help you, and I'll be looking forward to hearing from you. See you guys.